Okay. Welcome. Okay. All right. So we're moving on to, we're moving into proving triangles similar. Back in chapter 4, we were talking about, we learned all the different ways to prove triangles congruent, recall. And now we're moving on to proving triangles similar. And we're going to learn the first way today. So proving triangles similar. Recall, what does it mean for two triangles to be similar? The corresponding angles need to be congruent, and the corresponding sides need to be proportional. Okay? So, our first postulate, and if you recall from, was it Gizmos? The Gizmos activity? A lot of the questions were, why can't we have, to prove two triangles congruent, why is angle, angle, angle not on there? Right? And we learned because the two triangles could actually be similar if we had 3 sets. Ooh, try to make those look similar. If we had 3 sets of corresponding congruent angles, right? So that was not a way to prove two triangles congruent, but it is a way to prove them similar. So that's what this first postulate is saying. And we actually don't even need the third angle. We only need 2 angles. Because if we know 2 angles, then the third one has to be the same as well. Okay, because they all have to add up to 180 degrees. So this says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles will be similar. It's enough information. We call this, you can just call it AA, but it's the angle-angle similarity postulate. And here is, just to review, there's a similarity statement. There's a symbol for similar. All right, checkpoint. Determine whether the triangles are similar. If they are, write a similarity statement. All right, so, well, I see one set of angles that are congruent. Do you think we're going to be able to find another set of corresponding congruent angles? You might need your calculator. I mean, there's a 71 here, there's a 31 there, but we don't know what the third triangle is in each of those 2 triangles. What would this one be? 31? Because all 3 of those interior angles need to add up to 180 degrees. Okay, oh good. Well, now we have 2 pairs of corresponding congruent angles. So these 2 triangles are similar by AA. Because they're similar, we're now going to write a similarity statement which just says this triangle is similar to this triangle. So, would you like to, probably the easiest thing to do when you have a figure that has been rotated is to redraw it and then write your similarity statement. So I'm going to flip this around and redraw it in the same direction as this point and just make it smaller. Oh, pretend like, okay, not bad, right? All right, so that's G. 78 is here, right? And that is F. So this has to be H. All right, so what do you want to name the first triangle?
PRQ.
You want to start with P? PRQ. Okay, if we choose to name the first triangle PRQ, perfectly fine. Then we have to name the second triangle the same direction. Good. If we had chosen to name this first triangle like RPQ, then we have to name this one FHG. Yes?
Oui.
Excellent. All right, what about this one? What's the measure of this angle here?
110.
Did you check? That one's 27. That one's 53. Do you guys have calculators?
Uh-huh.
Okay, so break them out. Turn them on. Are you getting 110 or something else?
If you put 110 where Q is, it comes out to 190.
It goes 190.
Oh, yeah.
It has to be 100.
Yeah.
110.
That needs to be 100, and that's not the same. So we're not going to have two sets of congruent angles, so not similar. Very good. Okay, moving on. What thing? Actually, I was thinking about making this video, one of those Ed puzzle videos. Have you seen those? Where you go online and I'll show you in a little bit because I'm recording. And then you make the video stop and then have them answer questions and stuff in the middle. It's going to be awesome. All right, so show that the two triangles are similar. So RTV and RQS. All right, so the first thing I did was sometimes they like to draw triangles inside other triangles. So I just separated them and redrew them separately just so you can get a visual. This is the small triangle here, and this is the bigger triangle, RQS. Okay, but you'll notice when you draw them separately, we need to say this angle R up here, is the same measure in both of those triangles. So we need to add that. Well, once we add that and notice that we have that angle that's congruent, that's set, we've got another one here too, right? So we've got two sets of corresponding congruent angles. So it says show the two triangles are similar. We have, do I need to write something there? What should I write? Just to make it clear for the people listening at home. So right, two angles are the same, so the triangles are, yeah, that's how it works. Two angles are the same. So triangles are congruent by AA. Good enough. Really, it should be two sets of corresponding congruent angles. Okay, so remember how I've told you multiple times, anytime they tell you that lines are parallel, they never do that for no reason. They're telling you these two lines are parallel here. There's a reason. Okay? So I just kind of extended those two lines to just picture some parallel lines. And then here we've got, I just said, all right, well, if that's my transversal. Well, if we have, I need a different color here. We've got these corresponding angles that are congruent because those two lines are parallel. Well, now we've got two pairs of corresponding congruent angles. Yay! Angle, angle. So I'm just going to put a little arrow here. Corresponding angles. And then, oh, bless you. I'm going to try to use my camera tool. I've never used that before. Just to make this video longer, right? Because who wouldn't want to watch me for longer? How do I paste it? Oh, it had to be done on the computer. Hey, subscribers! Oh, look at that, it doesn't work. That was the first time I did that. All right. Okay. This is very wordy, okay? But a lifeguard is standing beside a lifeguard chair on the beach, which is where I want to be right now. The lifeguard is 6 feet 4 inches tall and casts. Do you guys know where we are in the paper?
Yeah.
Just flip it over and it's on the back. Okay. So here's the height of the lifeguard, here's the height of the chair, and they're both casting a shadow. We know the length of those two shadows. The question is, the chair casts a shadow that is 6 feet long. How tall is the chair? So here's your unknown. Bang, right there. All right, so we've got these 90-degree angles right there. There's one set of corresponding congruent angles. We actually have another angle up here because of the sun. So we have two sets of corresponding congruent angles, which make these two triangles similar by the angle-angle similarity postulate. So you have two pairs of congruent angles. So the triangles are similar by the angle-angle. Angle-angle similarity postulate. So now that we know the two triangles are similar, we can write a proportion because we now know their sides are proportional and solve for our unknown. So we're just going to go this is to this, this is to this. Okay? Except for his height is in feet and inches, so we first have to convert that into all inches. So what would that be? 6 feet 4 inches.
Hold on.
76.
Okay.
72, and then plus the 4, 76. All right, write 6 feet 4 inches as 76 inches, so you can form two ratios of feet to inches. All right, so okay. So now, see if you can fill in this proportion. You've got one unknown and three numbers. And they already put the unknown in a place for you. We're almost done. Height of the chair, we don't know. Height of the lifeguard, we do know. I'm going to put it right here. Okay? Length of the shadow, we know. Length of the lifeguard, we do know. That's just how I'm setting up mine. Cross multiply, divide, we get 6. Oops. Divide both sides by our 48. What are we getting for the value of x? Or the height of the chair? And then you have to divide by 48. This 456 by 48. What is it?
9.5.
Okay, so the chair is 9.5 feet tall. Easy peasy. All right, we have one more to do. I'd like for you to try it on your own. It's a proportion. You have to write the proportion. You got to convert a height. See if you can try it. Have this done on the next flip chart. Do, 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 do. Does that help? No. Do I look like Waldo?
A little bit.
Waldo? Keep working. There are different ways to write proportions. So yours might be set up differently than your neighbor. And that's okay. Do you think it's going to snow next week?
Yes, I will.
Pray.
It's supposed to talk.
I can't feel my legs! I can't feel my legs! Hi, everyone. And I like my hunt. Who's the funky looking donkey over there? That's it!
10 more seconds.
They missed you.
Okay, this is how I set mine up. Okay, but however you set yours up, you should end up with either 36 inches or 3 feet. Okay. So I started with this side, and I said, okay, well, the height of the lifeguard, I put the height of the lifeguard over the length of his shadow. Those are numbers I have, and I use them. Okay. So the height of this person over the length of their shadow. Now I'm using inches over inches. Okay, but if you end up using inches over feet or inches over feet on both sides, that's fine. But I end up cross multiplying and I get 36 inches. Depending on what you used, you might end up with 3 feet, and that's fine. How do we do? Ready for the homework?
Yeah.
Okay, thanks for watching.
Bye.
Like, comment, subscribe.
Yeah, subscribe now. Click like.